class, and welcome to R7. This is the last section in this chapter, our review chapter. So after this here, you'll be doing your review on your own, asking questions on it, and then you'll be taking a test. I hope you're doing great and keep commenting. All right, R7 is about radicals. We're going to simplify radical expressions and rationalize denominators. So when we go through here, there's a few things to remember. The nth root of anything to the nth power is going to cancel. What that's like if I say I want to take the cube root of x cubed. Okay, well the 3's are going to cancel because that's really x cubed to the 1/3 power. So 3 times 1/3 is 1, which gives you just the x on the inside. That's all number 1 is saying. Okay. Number 2, if you take the nth root of a to the n, this one's a little different since the n is on the inside. So this is like 3 squared is 9. Well, a negative 3 squared is also 9. So if n is even, you have the absolute value of a. You don't have 3 or negative 3. It can only be 3 because you have taken it to a positive power. If it's odd, it doesn't matter because it will keep the sign. This one here, if you have an nth root of both, that means I can multiply the numbers underneath as long as these two radicals are the same. The same is true when you divide. You can turn that into 1 depending on which way is easiest. And a root to a root means you multiply those exponents, just like before. So it's to the mnth root. All right, let's see how you're doing here. I would like you to give these a shot just to see how you remember, and then come back and check your answers with me. So I want to take the square root of 128. I know that 128 is 2 times 64. Well, the square root of 64 is 8. So we got 8 square roots of 2. 54 cube roots, and I'm looking for a perfect cube. So let's go over here. 54, I know, is 3 times 18. I know 18 is 9 times 2, and I know 9 is 3 times 3. So my perfect cube is actually right here, 3, and then I have the cube root of 2. Don't forget to do your roots correctly. So 3, if you just wrote this, that would be incorrect because you have to have the radical here, so you have to have your index. If you don't have the 3 on that ledge, then it's wrong because I do not know what's a cube root that you have found. I'm looking for a square root of 288. Well, I know that's 2 times 144. The square root of 144 is 12. So far, just working with the number, we have 12. And then we have, I'm going to leave a little room here, square root of 2. I've done the 280. Well, y to the 5th means there's 5 y's, right? So y, 2, 3, 4, 5. I'm going to do it the old way. I have 2 groups of 2. So that means I have y squared on the outside and a y left over on the inside. And I'm done because the square root does not need anything on the ledge. I cannot subtract these two unless they are identical. So I need to have a same square root underneath here. Well, I know 18 is 9 times 2. It's not working well today. So the square root of 9 is 3. So we take the 3 times the 2, which is the 6 square roots of 2. So remember, square root of 9 is 3, and then the 3 times the 2 is where we got that 6. Well, 32 is 16 and 2. Well, the square root of 16 is 4. So I'm going to take the 4 times the 5, which is 20. So I got minus 20 square roots of 2. Since they both had the same square root of 2, I can subtract their coefficients. So 6 minus 20 is a negative 14. Square root of 2, final answer. All right, right here, you can multiply, but you have to be a little careful here. Because multiplying, you just add exponents, right? I'm going to change these to fractions to actually make this easier. So this is x. This here means this is the 5 halves power. I have 5x, I'm taking the square root, so that's 5 halves, times this one here is x to the 5/3 power. Well, to multiply those, I have to add those exponents. So what I'm technically doing is taking 5 halves plus 5/3. I need a common denominator, which is 6. So this one needs a 3 numerator denominator. This guy needs a 2 numerator denominator. So now you got 15 plus 10 all over your common denominator, which is 6. So you've got 25 6. I would actually take that x to the 25 6th power. Also, if you had to reduce that, that's x to the 4th, because 6 goes into 25 4 times, so I have 4 full x's. I have 1 left over, so I have a 6th root of x left over. Actually, the correct way to write that. Now, I really want to know what you did on this last one. I'm hoping that you recognized that this was a perfect square. So that is x minus 2 quantity squared, and you were taking the square root of that. Well, the square root of x minus 2 squared is x minus 2. Technically, that's in absolute values because you have a square on the inside. Nicely done. Okay, rationalizing denominator. You have to remember your conjugate. You use these a lot with i's. So 5 plus the square root of 3, its conjugate is just where you change that sign in the middle. So its conjugate is 5 minus the square root of 3. This is nice because it's going to clear that radical. Let's show you. If you multiply conjugates together and you don't remember the shortcut, you take and you distribute. You get 25, and you've got minus 5 square roots of 3. Well, when you multiply this side, you get 5 positive 5 square roots of 3. So that square root's going to cancel. Then a square root times a square root is going to cancel itself, giving you minus 3. When you combine the like terms, those go away. You're left with 25 minus 3 is what you have, which is 22. You cleared your radical. So now we're going to use this to rationalize these denominators. So I need to clear these square roots. So to get rid of them, I just change that middle sign. So I take the square root of x plus the square root of y. That's going to clear those radicals in the denominator. I actually don't care about them in the numerator. They can be there, and that's all right. But whatever you do to the denominator, you must do to the numerator. So we have to write that down. So my numerator really doesn't do anything. That's y square roots of x plus the square roots of y. That's actually done. Now we're going to multiply the denominator. I know the square root of x times the square root of x is x. I know my middle term is going to cancel, so I do not need to do that step. The square root of y times the square root of y is minus y, and I'm done. Okay, I want you to pause and try yours, and then come back and see how you did. So you have 4 minus the square root of 2. So you should have said your conjugate is 4 plus the square root of 2, numerator and denominator. Okay, I'm going to leave my numerator alone for now. Okay, now let's see what we get in the denominator. I'm going to multiply this out. 4 times 4 is your 16. Square root of 2 times the square root of 2 is minus 2. Okay, when you do that, you get 3 times 4 plus the square root of 2 all over 14. Now, when you're looking at that, you're going to look and see if the 3 and the 14 will cancel. So if I can reduce those, I would. If this was a 15, this would become 1/5. Since they do not cancel, that is your final answer. All right, that's your last homework set for today for this actual chapter. Do well and ask questions.